9, and we're going to do problem number 2. And the pulleys supporting belts in a machine as part of a UHart engineering student's capstone project has equal belt tensions equal to 40 newtons, and the angle that you see right there is 30 degrees. The pulley has a radius of 80 millimeters, and the distance between A and B is 300 millimeters. We want to determine the equivalent force couple at point A, and express each, the force and the couple, as Cartesian vectors. Okay, so let me draw the problem out and get going. So I need to get home. So where'd you go? Mouse, there you go. Got the problems, looking a little isometric right there. That's like the Z direction. Here's the Y direction. And I'm going to freehand it. That's not great, but it'll do. Something like this right here. Getting mighty tired. Gotta go drive home still. Live like an hour away. So we get a force coming down on this belt. And this belt is moving over this way. Right there. And I guess they made the x-axis down the center right here. I guess that's what I decided to do there. Or somebody decided. Wherever I stole this from. I don't even remember where I get these from sometimes. Alright, so this thing has a angle right there of theta coming off right here, and this is A. I decided to call this B, and it's got a radius RB. I guess I put that over on the other side. And this is going to be ND, and this is going to be right here. This is C, so we have FC, and over here we have FD. Here's our X, Z coming out this way, Y coming up this way. We get a ZAB, kind of measured like to there, and anything else? No. So a given. We are told that FCDC is equal to FD is equal to 40 newtons, and we know that theta is equal to 30 degrees, and we have an RB is going to be equal to 80 millimeters, and a ZAB is equal to 300 millimeters, and we want to find the equivalent force couple system. At A. I would prefer to do this as the sum of the forces and some of the moments, but I decided to just stick with what the book does right here. So let's write out what FC is going to be. Is going to be a negative 40 in the J direction, newtons, whereas FD is going to be equal to a 40 times the, and by the way, you could tell by this being this angle right here that that's also going to be that angle right in there, right? Or you could say that it's that angle right in there, either way that you want to say right there. But that's going to be the cosine of 30 degrees, I, plus a negative 40 sine of 30 degrees. So, and these are newtons too. So what's 40 times 30 cosine, boom, 34.64 I plus our 40 and 30. Well, I know this. It's negative 20. Okay. And now we want to try to get, we need to move these forces over to here and find an equivalent force couple system. We don't really need to play the couple game, I don't think. We just find what the moments are going to be. So I'm going to find that my R, where this thing is located, right over there, from that position over to A, right there. I don't know how to say that correctly. I'm trying to think how I want to say where those things are happening. Oh, right in here. I wanted to give it a different name, but it's a couple. It's like coming from that spot where it's tangent over to right there, and I want to give it a new name. But see, I also want to call this one right up here where it's connected to the thing. So I'm going to give that one a new name. So I think I'm going to call this one just I'm going to call this one B1 with respect to A. So that's B1 and that's B2. I'm out of the letters, right? So that's what I'm trying to do here. So and the X direction was 0. All right, no, it's not true. The X direction, we're going to be a negative, let's stick with millimeters, negative 80 I. All right, it's going that way. And then in the we're going to B with respect to A, so we're going into the negative Z direction, so that's going to be the 300 J, and these are millimeters. And now I'm going to take my R and call it B2 with respect to A. That's the other location right here. So I'm going to call this one B2, and I'm going to call this one B1. And I don't know how many people are going to be able to get this. It'll be interesting to see what people come up with. Not interesting in that sense. Okay, so here we're going to have a positive, but it's going to be 80 times the sine of 30 degrees, right there, boom. And oh, and by the way, this should have been a 0J and plus negative 300 K millimeters. And then this one is a positive because it's coming in that direction right here. And then it's going to be a plus 80 times the cosine of 30 J, and then plus it's going to be also minus 300 K, because we're traveling this direction to get to right there, right? And these are millimeters. So let me rewrite that out. Nobody's going to get this. All right, so I'm going to write it out again. 80, 30 sine times, so 40 I plus 80, 30 cosine times, and that is definitely upwards. Okay, so 69.28 J plus 300 K millimeters. So the resultant of this, we could write that out right here. The resultant at A is just going to be negative 40 plus 34.64, so that's not going to do much, is it, in the extra, wait a minute, not true, that's all in the J. And this is actually not really a fair thing, because in reality it's going to go back to these 2 points, but I was trying to follow along with what they did in the book. Right. Okay. Let's take a 34.64 I plus my negative 40 plus my negative 20 J. So we're going to have a 34.64 I plus a negative 60 J, and these are newtons. And there's no K involved in this. But we do need to, when we do the moments by this thing, and we're going to do the moment at A, we're going to go R B1 with respect to A crossed with F C, and R B2 with respect to A crossed with F D. Right there. So we're actually going to take them where they last touch as part of this thing. And so that means we're going to have to do 2 of these wonderful things. Let's see. We're going to have to use more paper. Can't cram it all in here. So we're going to go equals I, J, K. And this one is going to be negative 80, 0, and negative 300. And the force for this is going to be 0 and negative 40 and 0. And then we're going to add that along with I, J, and K for 40, 69.28, negative 300, and the one that's up here where it's going to be 34.64 and negative 20 and 0. It's going to be a long one. Okay. So set them up, knock them down. This one actually we can just summarize right here. We know I is going to have something in here. J is going to have nothing, and K is going to have something. All right, so as we come here, we go I is going to be 0, 0, minus negative 300 minus 40. Here, right? So that's going to be I plus 0J. We don't need to bother with that one. Plus, and then K is going to be a minus 80 times a minus 40 minus, and then 0 times 0, so just 0 K. All right. Now we go to the next one down here, and maybe I'll keep writing onto here. So we go this crossed with that, that crossed with that. So it's going to have a 0, I'm just going to say with that, minus our minus 300 times our minus 20 I. right, so keep going. Now we might make sure we do this minus one right here, right? I'll write it as a minus right here. There's a minus right there. And then we go minus, and there's going to be the J, and it's going to be that crossed with that. So 40 crossed with 0, and then minus, and there's a lot of minuses here, minus 334.64 J, and then the last one, we're going to go and do this cross product, and nothing cancels out, unfortunately, on this one. Minus 20 minus 69.28 and 30. Is that a 34? Yeah, it's a 34. Looks like a 39 to me. 64. Okay. Newton millimeters. We've got to remind ourselves. So, are we going to cram it all onto there? Not good practice to do. Let me get all the I's together. So I'm going to write what the I's are. So it's minus, 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 so it's going to be minus. So it's 300 times 40, boom. So I get 12,000, right? So I'm just going to go ahead and say 12 Newton meters, right? Right. So, oh, wait. I'm sorry. I'm going to do this one too, right here, right over here. Right? So we go minus, 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 so it's still minus, and it's going to be 300 times 20. Boom. Add them together, and you get 18,000 Newton millimeters. So 18 Newton meters. Nothing here to report in the Y. So this Y right here is all uncertainty. So this is kind of confusing. This is minus, minus, but it's going to be minus. So it still ends up being minus. So it's 300 times 34.64. Boom. And so we get a minus, and this should have been minus 2, right? Yeah. So this is minus 10.39 J plus last one. We're in the home stretch. We're going to go minus minus, so we're going to go 80 times 40, and that one will be positive. So that's 3,200. And then this last one's got a lot of stuff in it. So we have a 40 times 20, but it is minus, so we will subtract it from there. And then we have a 69.28 and a 34.64, and that is also minus. Ooh, so we subtract it out. Boom. So about the z-axis, it's 0. That makes sense. It's balanced out. Yep. I should have figured that out. Should have just seen it. Yeah. Thing's gonna balance out right here, right? That is times this radius tangent, and this times that radius. It's gonna balance the thing out. No kidding. So the answers. We're going to say R at A, and I don't like saying this, but that's okay. 34.64 I plus negative 60 J. It actually should be about 1/2 of this, because the other bearing will support to do the dumb thing, but that's okay. This is not rocket surgery right here. K, and this is in newtons, and then M A. I hate trying to squeeze this in here, but it's not worth another piece of paper. And it's late at night. 18.00 I plus negative 10.39 J plus 0 K Newton meters. Box that thing up, put it in the bed, go to bed. So I'm not going to be able to record the videos that support this stuff for the next class. But good news is that I think I have videos recorded for a lot of the other classes this semester, so I can go ahead. It's 11 o'clock at night. We're going to go to bed. Mrs. Deal is going, honey, why are you working so hard? They don't pay you extra to do so. Like, I don't know. Just not able to get my job done in the allotted time, apparently.